Hi guys, welcome to Unacademy JEE English, a new channel by Unacademy, which is India's largest platform for JEE. Here, everything will be taught to you in pure English. Alright, today the topic that I'll be teaching is friction. Now, before I start that topic, let me tell you a bit about myself. My name is Rohit Dixit. I've studied mechanical engineering from IIT Delhi. I have 7+ years of teaching experience. I myself was JEE rank 447. I've coached many students to top ranks in IIT JEE, and I hope to do the same with lots of you. All right. Now, moving on, let's talk about the Unacademy subscription first. So, what are the benefits of Unacademy subscription? You have live classes, you can interact with your educators, you have live polls and leaderboards, you have test series and analysis, and best of all, you have live doubt clearing sessions. That is very important. Live doubt clearing sessions. Trust me, that is going to make a huge difference in your preparation. Plus, obviously, you get access to India's best educators. Now, how do you go about this? These are some simple steps which you can follow and take the Unacademy subscription. Please go through these steps. They are available in the video. And this is how you can subscribe to Unacademy, right? Follow these steps. These are coming up on your screen, I think, right? You can see these are the steps how you can subscribe. Next, okay, that is my code. RD Live. If you apply that code, you'll get an instant 10% discount. So, in case you want to start the subscription with my code, that's the code to apply, RD Live. All right. Now, let's get started. Friction. The reason why I picked up friction was that though it's a very simple thing, concept wise, the problem solving with friction can be pretty tricky. Students I know have faced a lot of problems with friction. So that is why I wanted to discuss this topic as my first lecture. All right. So, you know that there are some questions that you encounter in your daily life. Why can't you open jars with oily hands? How is a car able to accelerate on the road? What is the external force that is causing that acceleration? Why do we tend to slip on wet surfaces? And how does rubbing our hands together in winters gets them warm? The answer to all of them is friction. Now, when you hear about friction, you generally have a very negative view, right? However, that should not be the case. Why? Friction is very, very, very important. Imagine without friction, could you have discovered fire? You remember how fire was discovered? By striking two stones with each other. The thing that is causing that spark is friction. So without friction, we would have been in dark ages. Forget about fire, something as basic as walking, something like holding things in your hands. Those would have been impossible without friction. All right, me standing here, that would have been impossible had friction not been there. So friction is not all that negative. All right. So let's try and understand. The definition that we use for friction is that friction is a force that opposes relative lateral motion or tendency of relative motion between two solid surfaces in contact. So, one, it is opposing what? Relative motion, right? What is lateral relative motion? Lateral motion is when two surfaces are trying to slide over each other. This is called lateral motion. All right. So it not only opposes lateral motion. If the lateral motion is happening, then it will oppose this. Even if there is tendency of lateral motion like this, this has a tendency of slipping down my hand. It will oppose this also. So friction will oppose relative motion and as well as the tendency of relative motion, right? So how does this force come into play? It arises from a complex combination of intersurface adhesion, surface roughness, surface deformations, and surface contamination. Now, old theory about friction was that it is called by interlocking of irregularities. We all know that when we look at all surfaces under microscopes, all surfaces have these irregularities, these teeth kind of thing, right? And people believe that when two objects are placed together, these two irregularities get interlocked, and this is what is causing friction. Now, earlier, fine, everybody believed this, but there's a problem. Now, theoretically, you would assume if it is being caused by interlocking of irregularities, what happens if I remove all the irregularities or most of them anyway? Theoretically, I should be able to turn the value of friction to zero, right? So that is what people tried. They tried smoothing surfaces, right? And what is the expectation? The expectation is if you keep on smoothing the surfaces, the value of friction should keep going down and eventually should become zero. Now, here is where the problem came. Like up to a point of smoothing, it was going as expected. The value of friction was going down. But beyond a point of smoothing, the value of friction suddenly increases. And turns out it is almost impossible to make the friction zero. So it starts reducing, then suddenly it in fact increases. So that led us to believe that this theory of interlocking has to be wrong. So we needed a new theory. The new theory that came into place of this was, we now believe that the force of friction comes into play because of formation of cold welds at the contact points under high pressure. Now, if you look at the figure shown there, you will see that the actual area of contact is very small from the areas of two surfaces which are being put in contact with each other. In fact, experiments show the actual area of contact would be around 1 by 10,000 times smaller than the total areas which are kept in contact. Now, what does that mean? That means that because there are such small points of contact and all the force of normal reaction is being exchanged at these small points, very high pressure areas get developed here. Now, because of this high pressure, the molecules of the two objects in contact are pushed together, and they are pushed so close together that they start forming intersurface adhesive bonds. Now, they essentially get glued together under high pressure, right? Now, this is what we call cold welds. You guys know that there is normal welding, which is called hot welding. What do I do there? There we heat two objects and we bring their molecules close enough to each other to form welds. Here, the same thing is achieved by applying high pressure and bringing the molecules close enough to get them glued together. So now we believe that due to this high pressure, two surfaces form cold welds at the contact points, and these cold welds are the reason why friction exists. Now, this explains the anomaly that we observed in the experiment. Now, if you keep smoothing the surface, fine, the number of cold welds are reducing. So, the friction is expected to go down, which is what we can see happening. However, the moment you start smoothing the surface beyond a point, the pressure you realize at these points is going on increasing. You realize that beyond a certain value of pressure, when pressure is increased beyond a certain point, the nature of these bonds starts changing and it suddenly becomes very strong. And that is the reason why the force of friction eventually started increasing. So there are still a lot of theories, but this is the theory that is widely accepted right now. The formation of cold welds is causing the force of friction. Next, let's talk about some properties of this force. We know it is a contact force, and we know all forces are essentially one or the other manifestation of four fundamental forces. What are the fundamental forces? The force of gravitation, electromagnetic force, weak nuclear force, and strong nuclear force. So we know that all the forces that we see all around us are a manifestation of one of these four forces. So turns out friction is essentially electromagnetic in nature. Next, if you talk about direction, it always acts tangential to the common contact surface. So if the contact surfaces are like this, the common tangent will be along here. If suppose there were two spheres in contact, the common tangent would be along this line. So the friction always acts along the common tangent to the common contact surface, right? Now, in case there is slipping, then the direction of friction can be seen as that opposite to that of relative motion. Now, please note the term relative motion is very important. Relative motion. So if I keep this duster here and if it is moving on my hand like this, so what is the direction of relative motion of the duster with respect to my hand? It is this, right? So what will be the direction of friction? It will be here. Similarly, if this duster starts moving here, then the force of friction will act along this direction. And relative motion again. So even if my hand was moving itself, right, and the duster was still moving like this, the force will still act along this line and not in the direction of opposite to the direction of absolute motion. So the direction is determined only by the direction of relative motion. Please remember that. In case there is no slipping, the friction acts in the direction whatever is needed to prevent that slipping. I already showed you the example of that. If I have this duster in my hand, if I tilted it, what is the tendency of motion? It is along this line. So I know immediately that the force of friction must be acting along upward this direction, not anywhere else, because the tendency of slipping is downward. So the friction will act upward. All right. Next, it is a non-conservative force and causes dissipation of energy. Now, if you already know what non-conservative forces are, then very good. Even if you don't worry about it. We'll talk about this later. All right. So moving forward, let's talk about a simple experiment which will tell us more about friction. It will help us understand the nature of friction. In this experiment, what we are doing is that we keep a block and we start applying a force and we will vary the force on it. And we will see how it reacts to variation of this force. So initially, I know that this block is kept here. It's not moving. So because it's not moving, F equals ma equations tell me that the net force acting on it must be 0. Since I'm not applying any force, so what must be the value of friction right now? It must be 0. Why? Because it's not moving. F equals ma tells me that the net force is zero. Net force is zero. That means the friction value has to be zero right now. Right? Okay, let me apply a small little force. I applied a small little force, but it still did not move. What does that tell me? That tells me again that there must be a force which must be countering the force I applied. Right? Because F equals ma still is telling me that the net force is still zero. So how is the net force zero? If I'm applying this force, there must be a force which must be opposing my force. That is what friction is. Okay, how much will this force be? So let's say I applied a force of 1 Newton and I know it's not moving. So the force of friction right now has to be 1 Newton, right? To make the net force zero. Okay, let me increase my force slightly. It still did not move. So let's assume I made the force 2 Newtons. Now I immediately know that the friction must have immediately taken up the value of 2 Newtons. So I can see it is adjusting its value according to whatever I'm applying externally. So this force is changing its value. And if I apply small force and if I apply large force, immediately it changes its value. That is what we can see in the graph. See, in the initial part, you will see that the graph between the force of friction and the external force applied is a straight line of the angle 45 degree, right? Representing F equals F. So if I keep increasing my force, right? So beyond a certain point, I see that it starts moving. And when it starts moving, how do I calculate the force of friction now? Once it is moving, from its motion, I can calculate its acceleration. And using F equals ma equations, I can calculate the value of friction that must be acting now once it has started moving. So if I calculate these values and I start plotting them, that's the kind of graph that you'll get. So that graph is telling me that initially, before the slipping had started, the force of friction was increasing in accordance with the external force applied so that it could stop the motion. But beyond a certain point, it could not increase any further. In fact, its value drops suddenly and then it becomes constant. So we realized that the force of friction is acting differently when the slipping had not started and it becomes different once the slipping has started. So that is why we divide the force of friction into two parts, static and kinetic. Static friction is the force of friction that is acting between two surfaces when the slipping has not started. There is no relative motion. The force of friction acting is static. Now, once the motion has started, now the force of friction that is acting is called kinetic friction. All right. And from this graph, you can see that there is a maximum value to which static friction will go. That is called limiting friction. And then after that, kinetic friction will start acting. And kinetic friction seems to be lower than the limiting friction. Now, why must that be? There's a simple explanation to that. When I leave these two objects in contact, the cold wells that are getting formed are getting enough time to get set. Now, once this is moving, now every time this moves, it moves to this position. It tries to form cold wells, but I am immediately moving it to the next position. So the problem here is that I'm not giving the cold wells enough time to get set properly, because of which the cold wells which are being formed during motion are weaker to the cold wells which were formed earlier, which means these are easier to break. And what is the limiting friction? It was essentially the force required to break the initial cold wells. Now, once that happens, I know next time the cold wells getting formed are weaker than the original cold wells. And that is why the force of friction now decreases, because the force required to break the new cold wells is smaller. All right, let's talk about kinetic friction then. Kinetic friction we already discussed with the friction force that comes into play when there is slipping happening. Now, this is a relatively easier part of friction. So let's go over some properties of this friction. So first, let's talk about laws of kinetic friction. The first thing is it is independent of the area of contact. All right. Why is that? Now, normally you would assume if I keep the vessel like this, because the surface area in contact is higher, there must be more number of cold wells, right? And if I keep it like this, the number of cold wells must be lesser. So shouldn't it be more difficult to move it like this and should be easier like this? Why? Because there are more cold wells like this and smaller number of cold wells like this. Now there's a small little catch here. The catch is fine. How are the cold wells formed? They are formed by the pressure that is there existing at the contact points. Where is that pressure coming from? It's coming from normal reaction, right? So let's assume right now the area is A and all the N is distributed over an area A causing a certain pressure P, right? So that pressure P is determining the strength of the cold wells. So all right, there are more number of cold wells, but the pressure here will be lesser compared to when I put it like this. When I put it like this, you realize that the area has reduced because of which the pressure would have increased. A higher pressure is actually causing stronger cold wells. So that is why we practically observe that the net force of friction is independent of the area of contact. So do not make the mistake of thinking that if the area of contact is more, then the force of friction will be more. That is the first law of kinetic friction. It is independent of the area of contact. Please remember this. Now, second important law is that is independent of relative velocity of motion. Right? It doesn't matter if it is moving slowly over one surface or very fast. The force of kinetic friction is assumed to be independent of the relative velocity. All right. Here also there is a small little catch. Practically speaking, that is not entirely true. Practically speaking, the force of kinetic friction actually starts decreasing beyond a certain relative speed. But for JEE purposes, we ignore that. For the purposes of JEE, we will believe that it is independent of the relative velocity of motion. All right. How about the magnitude? Now, experimentally, I can find out that the magnitude of kinetic friction is directly proportional to the normal reaction. Again, you'll remember why is that? If I increase the normal reaction, what is happening? The pressure at the contact points is increasing. And I told you, higher the pressure, more will be the strength of the cold wedge. So if I increase N, okay, the number of cold wedges is same, but increasing N leads to higher pressure at the contact points. This higher pressure results in stronger cold wedge. So stronger cold wedge means more amount of friction. So we can see experiments show that Fk is directly proportional to N. If I remove the proportionality sign, I introduce a constant which we call mu k. Now mu k is called coefficient of kinetic friction. It is a unitless constant. The value of mu k depends purely on the nature of the two surfaces. If these two surfaces are there, they will have one value of mu k. If you change any of the surfaces, then you will get another value of mu k. So it is defined by the nature of two surfaces in contact. Now, problems when slipping is happening are relatively easy to solve. Why? One, you immediately know what force of friction is acting, kinetic. So, the moment you know kinetic friction is acting, the direction of this force is very easy to determine. You know what is the direction of this force? It is opposite to that of the relative motion happening, right? Secondly, what do you need? You also need the magnitude. You immediately know the magnitude is constant, right? No matter what kind of motion is happening. And it can be easily obtained from the equation that we have discussed above. Fk equals mu kn. So once I know this kinetic friction acting, I immediately know both the magnitude and the direction of this force. The moment both are known, I can easily solve my equations. All right. So let's discuss a couple of examples. In first example, see, most of the problems that you will encounter will be of these two kinds, right? Either you'll be given some data about motion and you'll be asked about finding the value of mu k, or the value of mu k will be given and you'll be asked to analyze the motion. Right. In the first example, I'm telling you things about the motion of an object and you're being asked to calculate the coefficient of kinetic friction. So let's go through that. A block of mass 0.5 kg is moving on a rough horizontal surface with an initial speed of 4 meters per second. If it comes to stop after moving a distance of 2 meters, find the coefficient of kinetic friction between the mass and the surface. All right. So I know if this was moving with an initial speed of 4, it eventually stopped. What caused it to stop? Must have been the force of kinetic friction. The force of kinetic friction stopped it. So first of all, if I can calculate the acceleration it or the retardation rather it faced while coming to stop, I can calculate the force of friction using F equals ma. So I know the initial speed, right? I know the distance traveled. Which equation do we use now? Remember, v square minus u square equals 2as. V is 0, right? U is 4, A and S is 2. So if you use V square minus U square equals 2S, what do you get your retardation as? The mod at least. Mod you get as 4 square, that is 16 over 2 times 2, which is 4. So you get 4. So 4 is the retardation. Alright. If the retardation is 4, now you can use F equals ma equation and get the force of friction. So F equals ma equation, what does that tell me? That the force of friction must be 4 times 0.5, so 2 newtons. 2 newtons is the force of friction acting. Now I also know that F equals mu k times n, and n is equal to mg, right? So mg becomes 5. So mu k would be 2 over 5. So that is 0.4, right? Everybody got it? This is a very simple example. Shouldn't be too difficult to understand. Okay, in the next example, you've been shown two figures, two blocks which are connected as shown. Okay, you've been given the values of the two masses and you've been asked to calculate the acceleration of the blocks and you've been given the kinetic friction coefficient here. So what do you do in this? You will see what is the driving force. M2G is the force that will be driving both and the opposing force will be the force of kinetic friction. Now, in this question, you are already being told that slipping is taking place, so you don't need to bother whether the force of friction acting is kinetic or static, because it is already given that the motion is happening. So you know the force of friction is kinetic, and since you know the coefficient of kinetic friction, you immediately know the opposing force. All right. So the force driving both the objects is m2g, which is 40 newtons, right? And since the n between m1 and surface will be 6 times g, which is 60 newtons, and the coefficient of kinetic friction is 0.5, so the opposing force of kinetic friction will become 30 newtons. So 40 newtons of driving force, 30 newtons of opposing force. What is the net force? 10 newtons. So 10 newton is the net force driving both these masses. And we can divide the net mass of both of these, which is 10, with the net driving force and get the acceleration. So the acceleration of these two masses comes out to be 1 meter per second square. Easy enough? Okay, let's move on. Okay, now let's talk about the tricky part. Let's talk about static friction. So the first most problematic part about this force is that it's a self-adjusting force. We saw that when I applied a force of 1 Newton, it took up a value of 1 Newton. When I applied 2 Newtons, it changed its value automatically and took up a value of 2 Newtons. So that's the biggest problem with this force. It's a self-adjusting force, and it can take up any value from 0 to maximum value, which is called limiting friction. Now, what value will it actually take in a situation? I know there is one aim that static friction has. That aim is to prevent slipping between two surfaces. So what value does it want to take? It wants to take any value which will allow it to prevent slipping, right? So that is what you have to remember. Okay, now let's talk about some laws of limiting friction. Again, the first law that you will study is that it is also independent of the area of contact. This goes by the same logic that we discussed in kinetic friction. Secondly, again, the force of limiting friction is directly proportional to the normal reaction between the contact surfaces. This follows the same logic again. More normal reaction means more pressure on contact points. More pressure on contact point means stronger cold winds. So higher value of limiting frictions. All right. So I can say that Fs max is directly proportional to N. And if I remove the proportionality constant, then I get a constant, and which is called μs. μs is what we call the coefficient of static friction. All right. Now, in general, Fs will always be less than equal to μsn. So Fs will always have a value from 0 to μsn. All right. Now, the value of μs, how do I know that? That depends purely on the nature of two contact surfaces, and it will be determined experimentally only. If you have some data, on the basis of that data, you can determine the value. Otherwise, it is determined experimentally. All right. Now, let's talk about problem solving with static friction. Now, the problems where there is no slipping can be very tricky. Now, why is this so? First, whenever there is no slipping, you know that the force of friction that is acting must be static in nature. All right. Now, the tough part in such cases is that both the direction and magnitude of this force may be difficult to judge. You understand? That's the problem. To solve any problem, I need to know all the forces that are acting on a body, right? And what do I need to know about forces? I need to know two things, right? The direction and the magnitude. Now, problem with static friction is that often it will be very difficult to judge both. So that is what makes the problems involving static friction very complicated. Now, the first thing that we discuss is that the direction of force is opposite to the direction of tendency of slipping, which might not be very easy to see, right? Like if I keep something like this, if I show you an example like this, here it might be easy, but I can bring out a complicated situation where it might be difficult for you to judge even the direction of tendency of slipping. However, there is a small trick to that. You can easily determine this direction by imagining what happens when there is no friction. So whenever you are having a tough time determining the direction of tendency of slipping, use this trick. All right. You imagine what happens if there was no friction at all. You try and solve the problem like that, assuming no friction. Now, in case of no friction, whatever be the direction of motion, that will be the direction in which there will be tendency of slipping with friction. So the moment you know the tendency of slipping, you immediately know the direction of action of static friction. It will be right opposite. Now, we remain with the second part of the problem, which is finding the magnitude. Now, the problem is magnitude can be anything. It can be anything from 0 to limiting friction, right? What value? I discussed this earlier. The actual value will be determined as to whatever is required to prevent slipping, right? So what will the force of friction do? Force of friction will say, okay, this guy is trying to slip. So what is the force required to prevent slipping? Whatever is the value required, it'll take that value out, right? And this value can be found out by using F equals ma equations, right? Do not make the careless mistake of blindly substituting Fs equals Msn everywhere. That's a very common mistake. That is where most people go wrong. The moment you see static friction acting, you put the value of Msn there. That is not the case. That's only limiting friction. Please remember that static friction can take up any value from 0 to Msn, right? And the value taken will depend on the requirement. So you need to see what is the force required to prevent slipping first, and then only you can judge the magnitude. Do not blindly put the magnitude everywhere as μsn. All right, let's take up an example. In this example, I've shown you a block of 5 kg resting on an inclined plane, and you've been asked to find the force of friction. All right. So let's talk about all the forces that must be acting on this. So when I have one mg which is acting vertical, mg will have two components, mg cos theta and mg sin theta, right? So as the angle of the incline is 37, mg cos theta will be, how much is cos 37? Cos 37 is 4 by 5 and mg is 50. So 4 by 5 times 50, that becomes 40. So mg cos theta 40 newtons is acting like this, and mg sin theta, what is sine of 37? That is 3 by 5. So mg sin theta becomes 30. All right. So when a block is kept like this, mg cos theta of 40 newtons is acting like this, and mg sin theta of 30 newtons is acting like this. All right. What do we need to judge now? We need to judge how much friction is acting, right? And we know how to judge the magnitude of static friction. We need to see what is the force required to prevent slipping. So when I see my situation on the block, you have 40 mg component of 40 newton acting like this. This will be compensated by a normal reaction coming from the incline. How about this mg sin theta of 30 newton? That's the only unbalanced force which will cause it to move, right? So if I can balance that force, then I can prevent slipping. So to balance a force of 30 Newton down the incline, I need a force of 30 Newton up the incline. So in this case, I know both that the static friction acting will be up the incline, and how much of static friction will be acting? 30 Newtons. All right. Now, if you talk about the limiting value of friction in this case, we already realized that N in this case was 40 Newtons, right? So N in this case was 40 Newtons. We've been told that mu s is 0.8, which makes the value of limiting friction mu s times N as 32. So in this case, though the value of limiting friction is 32 Newtons, we realize that the force of static friction acting is only 30 Newtons. Why? Because you need to remember mu s n only gives you limiting value, right? But the static friction takes up whatever value is required to prevent slipping. So you need to be very careful when dealing with static friction. All right, remember that. For static friction, it will take up any value which is required to prevent slipping, right? So next, let's go through a checklist of friction problems. So whenever you have friction problems, there will be three cases. One, either there is slipping happening, or you'll be told an object is just about to slip. And third case, when there is no slipping. So let's go over all these cases one by one. In case there is slipping, then you immediately know both the direction and the magnitude of the friction force acting. Why? Because you know the force of friction acting is kinetic. And we have already spoken about this, that for kinetic friction, you can easily determine the direction and magnitude both, right? Next, okay, listen to this carefully. If your question says that something is just about to slip, then you must realize immediately the force of friction acting is obviously static and it is at its limiting value. Just about to slip hints you that the static friction has reached its limiting value. So the moment your question says just about to slip, you immediately know the magnitude of static friction. It is equal to the limiting friction, right? And then finally, the third case of no slipping. In the case of no slipping, you can find out the magnitude of friction by using the F equals ma equations. You know how much friction would be required? We already discussed whatever is required to prevent slipping. So we will see how the blocks are behaving without friction, and then we will try and imagine what is the force that would be required to prevent this motion, and that can be calculated using F equals ma equations. Now in both just about to slip and no slipping conditions, as far as direction of friction is concerned, that can be found by help of again determining the motion without friction. So once you have this checklist, remember, whenever you have a problem, let's say related to static friction, You will imagine that there was no friction. You will solve it like that. You will see all the forces. And then you'll try to find out what is the force of friction required to prevent this slipping. Then you need to do one thing. You need to just check whether this required force to prevent slipping lies below the limiting value or not. If it lies below the limiting value, then we don't have a problem. Just in case it exceeds the limiting value, then then I immediately know, okay, in such a case now slipping must happen. Why? Because the amount of friction required to prevent slipping becomes more than the limiting value. That much friction cannot come. So in such a case, slipping will happen. And the moment I know slipping will happen, I know the friction force acting is kinetic. I will apply kinetic friction and solve the problem again easily. All right. So I hope this video helped you guys with your problem solving. The next time you can, in fact, after watching this video, try and solve some problems of your own. And remember this checklist, right? This checklist will really help you. You identify what case you're dealing with, then you immediately know what steps to follow. All right. Good luck with your question solving and let me know in the comments if this video helped. All right. Next, let's talk about the subscription again. I had already told you steps, and let me remind you, these are the easy steps to get the Unacademy subscription. All right. And my code again, RD Live. Remember my code? My code is RD Live. All right. And if you liked the video, please press the like button and share it with your friends. Try and help as many people as you can. And also don't forget to press the bell icon. Also, the slides used in this video are also available in PDF format, so you can download it. Right. One more time. My referral code is RD Live. Get 10% off using this referral code. And I hope this video helps you solve your problems. Do let me know in the comment section about whether it helped you or not, or any other things that you would want to discuss. Thank you for now. Bye bye.